Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Zafri based in Zafri. My matric number is 2310301. What if I told you that all you think you know about addition reactions may be incorrect? Don't worry, I will help you learn more about them, and there are various types today. We need to understand the learning aim before I begin. So the first one, let's review the objectives. Specifically, what is an addition reaction? Secondly, what is its type and mechanism of operation? So as we can see on the slide, what is addition reaction? An addition reaction is a reaction that adds two compounds together to make a new compound. In this reaction, a double or triple bond is broken to form two new single bonds. Addition reactions typically involve an electrophile and nucleophile. So we move on to the next slide. We have two types of addition reactions. The first one is polar addition and non-polar addition. In polar additions, we have electrophilic addition reaction and nucleophilic addition reactions. For the non-polar, we have free radical and cycloaddition, but I'm going to talk about polar addition only. So we move on to the next slide. Polar, we have electrophilic and nucleophilic. For electrophilic, an addition reaction in which a reactant with multiple bonds, as in a double or triple bond, undergoes its pi bond broken and two new sigma bonds are formed. The electrophile is usually an electron deficient species that can accept electrons. The last one is nucleophilic. Nucleophilic, an addition reaction where a chemical compound with an electron deficient or electrophilic reacts with a nucleophile, which is an electron-rich reactant, with the disappearance of double bond and creation of two new single or sigma bonds. As we know, the nucleophile is electron-rich. So that's from me, and I will pass to Zam.
Thank you to Brother Zafri. My name is Muhammad Zamfaris Izzuddin bin Muhammad Sabri, and I'm going to continue the presentation with the example of addition reaction. Okay, the first one is the hydrogenation of alkenes. Hydrogenation is the addition of hydrogen into an alkene, converting it into an alkane. For this reaction, ethene is reacted with the hydrogen gas in the presence of metal catalyst, which is nickel. The double bond in ethene breaks, and each carbon form a single bond with the hydrogen atom. As a result, ethane is produced. The reaction happens under high pressure with the help of metal catalyst. Moving to the next one is hydration of an alkene. Hydration is the addition of water to an alkene, forming an alcohol. For this reaction, ethene reacts with water in the presence of an acid catalyst, which is phosphoric acid. The double bond in ethene breaks, and a hydrogen atom attached to one carbon, while a hydroxyl group joins the other. As a result, ethanol is produced. This reaction happens in room temperature. The third one is halogenation of an alkenes. Halogenation is the addition of halogen atom across the double bond. For this example, ethene and bromine gas is combined. The double bond in ethene breaks. Each carbon forms a single bond with a bromine atom. The outcome is 1,2-dibromoethane. This transformation also happens at room temperature. Finally, the addition of hydrogen halide to alkenes to form alkyl halides. So in this case, the ethene is reacted with the hydrogen bromide. The double bond breaks, and each carbon form a single bond with a hydrogen and a bromine atom. Therefore, ethyl bromide is formed. This reaction happens at room temperature. That's all for me. Thank you.
Assalamualaikum, my name is Zulfa. In this video, me and Yusop will talk about substitution reaction. So what is substitution reaction? Substitution reaction is a reaction in which a functional group of a chemical compound is substituted by another group. This reaction also involves the replacement of one atom or molecule of a compound with another atom or molecule. So there are two main types of substitution reaction, which is SN1 reaction and SN2 reaction.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Yusop and my metric number is 2313391. Okay, now in this video, I will present about SN1 reaction. So basically, what is SN1 reaction? The SN1 reaction is a nucleophilic substitution reaction where the rate determining step is unimolecular. SN1 stands for substitution nucleophilic unimolecular. This reaction involves the formation of carbocation intermediate. So, mechanism of SN1 reaction basically have three steps. The first step is ionization, or we call it as rate determining step. The second step is nucleophilic attack, and the third step is deprotonation. Okay, now we go to the next page. So, in the next page, we have an example of hydrolysis of tertiary butyl bromide. So, from the word hydrolysis, we know that in this experiment, we react tertiary butyl bromide with water. So, step 1, in this reaction, the cleavage of CBr bond occur. The cleavage of this bond allows the removal of bromide ion. When the bromide ion leaves the tertiary butyl bromide, a carbocation intermediate is formed. So note that the formation of carbocation intermediate is endothermic reaction. So step 2, the carbocation is attacked by the nucleophile. Since water is used as a solvent, an ozonium ion intermediate is formed. So note that the nucleophilic attack can occur from either side of the carbocation. Step 3, the positive charge on carbocation was shifted to oxygen in previous step. Since the ozonium ion has positive charge, water solvent now acts as a base. It deprotonates the ozonium ion to yield the required alcohol along with hydronium ion as a product.
Now let's talk about SN2 reaction. SN2 or substitution nucleophilic bimolecular is a reaction occur when a nucleophile attacks or pushes off the lipid group from its point of attachment to carbon. SN2 reaction is a one-step reaction, referring to bimolecular transition, meaning that the substrate coordinate closely both to the nucleophiles and to the lipid group simultaneously in the transition state. In this reaction, we want to identify these three key players, which is nucleophilic, electrophilic, and the lipid group. So how SN2 reaction occur? So here's one example, the reaction between methyl chloride and hydroxide ion. So before we go any further, let me remind you that this reaction is always go from electron rich to electron poor. So here, hydroxide ion is a nucleophile, is act as a nucleophile, so it is an electron rich. So when the nucleophiles attack the carbon from the side opposite the bond to the lipid group, which is a chloride, the hybridization of carbon at which substitution occurs changes from the sp3 to the sp2 in the transition state. So both nucleophile and the lipid group are partially bonded to this carbon in transition state. So once past the transition state, the lipid group is as well. So the formation of nucleophiles to the carbon occur. So it makes that the hybridization returning to sp3. So at the end, the substrate is invert as it is undergo nucleophilic substitution with inversion.
My name is Alia Zafirah with metric number 2313556. So I will proceed with the last reaction, which is elimination reaction. What is elimination reaction? An elimination reaction is a reaction that involves removing specific atoms or group of atoms, creating double or triple bonds. This reaction also involves the removal of element to create unsaturation, typically elimination reaction catalyzed by acid or base. There are two main types of elimination reaction, which are E1 reaction and E2 reaction. For my part, I will focus on E1 reaction. E1 reaction, also known as the unimolecular elimination reaction. In E1, a leaving group and a proton are eliminated from the same molecule. The E in E1 stands for elimination and 1 indicates a single molecular species in the rate determining step. There are two mechanisms for E1 reaction, which are formation of carbocation and deprotonation. Moving to the example of E1 reaction, the substrate in this case is 2-bromo-2-methylbutane. The carbon-bromine bond in the alkyl halide is polarized, with carbon being partially positive and bromine being partially negative. In the ionization step, the carbon-bromine bond undergoes heterolytic cleavage, meaning that the bond is broken in a way that one atom retains both electrons, resulting in the formation of a bromide ion and a carbocation. The carbon atom that originally had the bromine becomes a carbocation. Moving to the second step, after the ionization, ethanol serves as a weak base in this step. The lone pair of electron on the oxygen atom of ethanol can act as a base, and it abstracts a proton from the positively charged carbon. The deprotonation results in the formation of the alkene product, which are 2-methyl-1-butane and 2-methyl-2-butane and a water molecule. The water molecule is formed because of the proton that is removed combines with one of the hydrogen atom from the ethanol.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ainin Sofia binti Yusop and you can call me Ainin. My metric number is 2310048. Now, in this video, we are going to focus on E2 reaction. The E2 reaction, also known as the bimolecular reaction, it is a type of organic reaction involving a one-step mechanism in which carbon-hydrogen and carbon-halogen bonds breaks to form a double bond, which double bond pi bond. The E2 in this reaction stands for elimination, and the 2 indicates that the reaction rate depends on both concentration of substrate and concentration of the base. Meaning that in this E2 reaction, it is a conservative reaction mechanism. It all happens in one step, and so there are no carbocation rearrangement. It is the first order with respect to the substrate, and it is the first order with respect to the base. But it's the second order is overall. For example, if you double the concentration of the base, and if you triple the concentration of the substrate, your rate will increase by the factor of 6. Another example, if you quadruple the concentration of the base and you increase the concentration of substrate by the factor of 5, then your rate will increase by the factor of 20. Now, let's move on to the example. Here in this E2 reaction, we have a secondary alkyl halide reacts with, let's use a strong base, which is the sodium ethoxide dissolved in ethanol. Now, sodium ethoxide is going to go for red hydrogen and as opposed to the yellow hydrogen. When you use a strong base that is not as strictly hindered, then it's going to go for the hydrogen that leads for the data of the product, because it is the most stable alkene. Then in this reaction, a red hydrogen will form a carbon-carbon double bond, and it's going to be the major product, which we can call it as a Zaitsa product. If it goes with yellow hydrogen, then it will form the minor product, which we can call it as a Hoffman product. Okay, that's it.
Assalamualaikum, my name is Aina and I will continue with real life application. So, the reaction of addition, elimination and substitution are crucial in organic chemistry. They play a vital role in the synthesis of various compounds and material. For example, the addition reaction are important in polymerization of monomers to produce plastic like polyethylene. Elimination reaction in dehydration of alcohol in production of biofuels, and substitution reaction in metabolic processes in human body. So next I will story about how substitution reaction took a part in the history of how chemotherapy are invented. So during World War I, mustard gas is used as chemical warfare in 1917. So mustard gas causes severe burn. Soldiers that are exposed to this gas experience significant health issue, and this lead to a lot of total death, a lot of number in total death. So after 2 decades, when World War II is looming, medical researchers tried to create antidote because they feared that the repeated of mustard gas attack. But somehow this led to discovery of destroy lymphatic tissue by the mustard gas. So they thought that mustard gas might also able to kill the cancer cell in the lymph node. So of course, fighting cancer with mustard gas would be very dangerous to the patient. So the chemists or researchers went back to their benches, and they found that by replacing or substitute the sulfur in the mustard gas with nitrogen, were able to treat cancer and reduce some of the toxic side effect in human. So this compound is called nitrogen mustard. So after this discovery, Dr. Alfred Gilman and Dr. Louis Goodman conducted experiment with nitrogen mustard compound, especially mechlorethamine. So in the early 1940s, nitrogen mustard compound were used in the treatment of lymphoma, marking the beginning of the modern chemotherapy. And the success of nitrogen mustard experiment led to the development of various chemotherapy drugs, including alkylating agent and antimetabolites. So in summary, substitution reaction play a crucial role in the evolution of mustard gas into chemotherapy. So the success of substitution reaction from weapon war to valuable medical tool marked a significant turning point in the application of chemical knowledge for beneficial medical purposes. So in conclusion, addition, elimination and substitution reaction are the toolkit for chemists to manipulate or tailor molecular structures. This will enable to the creation of material or compound with specific properties. So understanding the mechanism and application of this reaction is the foundational for advancement in drug development, material science and various industrial processes. So that's all from me and my groups. Thank you.
Electrophilic addition is a reaction between an electrophile and nucleophile that is added to carbon-carbon double bond, which is an alkene. An electrophile is defined by a molecule that has tendency to react with other molecules that containing a donatable pair of electrons, or we can call the electrophile as electron lover. So the mechanism of the reaction is when the hydrogen atom from the HBr is attacked by the double bond to form a CH bond. This will leave another carbon with a positive charge and bromide ion. Bromide ion then use its electron to form the bond with the carbon with positive charge and produce one bromoethane. However, there are two possible carbon cation if unsymmetrical alkene react with unsymmetrical reagent. As you can see, when the carbon cation is at C1, it will lead to major product, while when the carbon cation at C2, it will lead to minor product. Here, we can see that the hydrogen atom will be added to the carbon that has fewer alkyl substituent, while the bromine will be added to the carbon that has more alkyl substituent to get the major product.
This is all happening due to the carbon cation, which is an atom with positively charged, and there are two factors that cause the stability of the carbon cation. The first factor is the inductive effect. It is kind of sort of shifting the electron density from the alkyl substituents to the carbon cations. The more the alkyl groups, the bigger the stabilizing effect. Second one is the hyperconjugation. It is the stabilizing interaction between the p orbital and the neighboring sigma bond at the CH, the parallel. The more the alkyl group, the more stable the carbon cation. Now we know that carbon cation that is surrounded with three groups is a tertiary carbon and the most stable, while methyl with no substituents is the least stable among the carbon cation. It's actually called Markovnikov's rule and explain why we get this as major product and this as minor product. Here is one example of the electrophilic addition when the 2-methylpropene added with the hydrochloric acid. Another addition reaction is the free radical addition, which is involved free radicals. In previous reaction, we need to follow the Markovnikov's rules to get the major product, which stated that H atom will be attached to the carbon with zero alkyl substituents. But in this reaction, it will differ from the Markovnikov's rule. There are three steps in this reaction. First is the initiation step, which is the formation of the free radical. The electron will transfer one by one from the H2O2 and not as a pair, and HO free radical will be produced and combined with HBr. This will lead to the free radical of Br that are highly reactive. Second step is the propagation step, which is more free radicals will produce and combine with molecule to produce another free radicals. The propagation step will stop when the termination happens. The termination is when the two free radicals bond with each other and produce a molecule.
First, I will be explaining about carbon anion before we proceed to nucleophile. Carbon anion is very reactive species with a negative charge on a carbon atom. Let's take a look at the example. Here we know that carbon is more electronegative than lithium. So pair of electrons will transfer to the carbon. It will produce carbon anion and lithium as decayed ion. Nucleophile is an electron-rich species which attack low electron density carbon atom by donating an electron pair to form a covalent bond. Low electron density carbon atom means a positively charged carbon atom or carbocation. A nucleophile can be either neutral or negatively charged. Next, let's take a look at nucleophilic addition reaction of aldehyde and ketones. We assume that this is nucleophile. An electron pair from the nucleophile adds to the electrophilic carbon-carbonyl group, pushing an electron pair from the C double bond O onto oxygen and giving an alkoxide ion intermediate. The carbonyl group rehybridizes from sp2 to sp3. The next step is protonation of the alkoxide and ion intermediate give the neutral alcohol addition product. For the first example, it is nucleophilic addition reaction of ketone. Cyclopentanol react with methyl magnesium bromide, which is Grignard reagent, will form 1-methyl cyclopentanol. For the mechanism, pair of electron from methyl, which is nucleophile, will attack carbon atom, which is electrophile, pushing an electron pair from C double bond O onto oxygen, and it will form alkoxide ion. Pair of electron from oxygen will attack hydrogen, and pair of electron here will attack oxygen. It will form 1-methyl cyclopentanol, which is tertiary alcohol. For the next example, it is nucleophilic addition reaction of aldehyde. Butanol react with methyl magnesium bromide will form pentanol. Let's see how it is formed. An electron pair from methyl, which is nucleophile, will attack carbon atom, which is electrophile, pushing an electron pair from C double bond O onto oxygen. Will form alkoxide ion. Pair of electron from oxygen will attack hydrogen, and pair of electron here will attack oxygen, and it will form pentanol, which is secondary alcohol.
So hi, I am Anuar Hakim. My batch number 2315801. So I need to explain the elimination reactions. So we move to the definition of elimination reactions. Elimination reaction is a type of organic reaction in which two substituents are removed from a molecule to form a new double bond or pi bond molecule. And then the elimination reaction have two types. The first type is a unimolecular elimination reaction, or as known as E1 reactions, and the second type is bimolecular elimination reaction, or as known as E2 reaction. So why we need to study this elimination reaction? So basically, in elimination reaction, we need to convert the saturated compound into the unsaturated compound. Second question is, elimination reaction endothermic or exothermic? Elimination reaction is a endothermic reaction because of we need to remove a substituent. So when we need to remove a substituent, we need energy to break the chemical bonding. And in elimination reaction, we must have the high temperature. Right, we move to the graphic. Here, as the graphic, they need to remove two substituent. Here, hydrogen NCN. We have alcohol here in the saturated compound, so we need to convert it into unsaturated compound. Here we have 18. Right, basically, elimination is the opposite of addition reaction. So E1 occur when they have high temperature, they have weak base, and they need to have the beta carbon bonding. Right. So the first thing is elimination reaction have two steps. E1. So I explain in E1 reaction. In E1 reaction, they have two steps. The first step is formating carboxylic ion, and the second is deprotonation or attack the nucleophile. Right. For the formating carboxylic ion, the first thing is we need to leave in the group of the halogen. We need to leave the Cl alone with a pair of electron together. Here, like this. And here, the alpha carbon bonding will become a carboxylic ion after the leaving group of Cl. The carboxylic ion is positively charged. So that is a formating carboxylic ion. Then we move to the next step is deprotonation or attack the nucleophile. In this step, they have a Lewis base. So basically, in one reaction, we use the weak base. And as an example, I use a hydroxide. Here, hydroxide will attack the hydrogen in the beta carbon bonding, and it will form a hydrogen. It will form a water here. And the carbon at beta bonding will form a new bonding with alpha bonding. It will form a double bond here, a new pi bond. So that's lead to the final product of elimination reaction.
My name is Haziq bin Kasmani. Today I will present to you about E2 elimination reaction. Okay, E2 elimination reaction is defined as a type of reaction where a molecule loses two substituents, resulting in the formation of a double bond or alkene. So next, the mechanism. The E2 elimination occurs in a single step where a base extracts a proton from the alpha carbon while a leaving group departs. And lastly, the aspect of radial selectivity. E2 elimination typically follows Zafirah's rule, where the more substitute alkene product is favored. So next, we will move on to the mechanism of E2 elimination reaction. So there are step-by-step process. The first one is alkene formation. So the carbon ion and carbocation combine to form a double bond, resulting in the elimination of two substituents. So the next, base abstraction. A strong base abstracts a proton from the alpha carbon, resulting in the formation of a carbon ion. And lastly is leaving group departure. The leaving group, which is typically a halide or a sulfonic group, departs and creating a carboxylic ion. Factors that affecting the E2 elimination reaction. So the first factor is base strength. A stronger base leads to a faster and more efficient E2 elimination reaction. The second factor is temperature. Higher temperatures increase the rate of E2 elimination by providing more energy to the reaction to occur.
and the last factor is steric hindrance. Okay, next we will take a look at this example, E2 elimination reaction. So we will have to consider it primary alkyl halides, and we will use the strong base in this reaction. We will use alcohol, potassium hydroxide. So why we take a strong base is to pull the beta hydrogen easily. So where is the beta hydrogen? Is at this carbon. Why this is alpha carbon. So when we react with the potassium hydroxide, we will get Kx plus H2O plus CH3 single bond CH double bond CH2. So why we get like this? So we take a look at this nucleophile is provided by KOH. What is nucleophile? Nucleophile is OH minus. So OH minus will attract H from this beta carbon. So it will become H2O, and while X will be attracted by the K, and we will form a new compound KX. So that's why double bond is formed at here. So at the end we will get KX plus H2O plus CH3 single bond CH and double bond CH2.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad Khairulanam bin Muhammad Rizal, and my metric number is 2314807, and I'll be presenting about substitution reaction about SN1 mechanism. Alright, so for the SN1 mechanism, I will explain it briefly. So in SN1 reactions, a molecule breaks into two parts. One part leaves, which is called a leaving group, and this leaving group is usually a halide ion. And once it leaves, it will create a positively charged center, which is called carbocation. This positively charged center is unstable and will attract other molecules called nucleophiles. And the nucleophile will attach to the carbocation, replacing the leaving group, and forms a new compound. SN1 reactions typically happen in two steps and usually involve molecules that easily lose apart and become reactive. That's all. Alright, moving on to SN1 reaction example. Here we have third butyl bromide react with water. Alright, so when third butyl bromide interacts with water, it will undergo a chemical reaction. The bromine part of third butyl bromide will be replaced by a part of the water molecule. This change creates third butyl alcohol and hydrobromic acid as products. This reaction happens because third butyl bromide is a type of molecule that easily lets go of its bromine part when comes contact with water. Then water will add a piece of itself to the third butyl molecule, making a new substance called third butyl alcohol.
Assalamualaikum, my name is Aqilah. My metric number is 2319450 and I will be present as an reaction. In every substitution reaction, there's three important things. The first one is sp3 hybridized C, nucleophile, which represent as Nu in this picture, and the leaving group, which represent as X. Reaction mechanism for SN2 reaction. Nucleophile will attack the carboxyl ion, usually from the back side relative to the location of the leaving group. It can't approach from the front side because of the leaving group is also an electron-rich group, thus it will repel each other. Bond breaking and bond forming occur at the same time, and there's no intermediate involved in SN2 reaction. Factor that lead to SN2 reaction is, first one is substrate alkyl halide. For SN2 reaction usually occur on methyl halide primary and secondary carbon. The reason why it doesn't occur on tertiary carbon, as the greater steric hindrance between the nucleophile and nearby group of substrate will lead the SN1 reaction to occur first. If the SN2 reaction happens, the reaction will be very slow. As you can see, this is the tertiary carbon. The bulky group CH3 have a great steric hindrance, therefore if the Cl leave the ethyl group will be stable. which will lead to the SN1 reaction. In SN2 reaction, it is difficult for nucleophile to attack the tertiary carbons because of the bulky group, which will make the reaction very slow that tend to be not occur. Second one is the nucleophile. A strong nucleophile always favor SN2 manner of nucleophilic substitution. Due to the strong nucleophile, SN2 reaction don't need an intermediate carbocation to occur and only have one step of mechanism. Example of strong nucleophile is OH minus and CH3O minus. For SN2 reaction, this is the example, which is bromomethane react with strong nucleophile OH minus. What will happen is CBr bond begin to break. Bonding pair will become lone pair on Br. The OH minus nucleophile will attack from the back 180 away from the leaving group. Then the lone pair electron begin to form new bond with the carbocation. As you can see, this is the transition state. Bond breaking and bond forming is happen at the same time. Then the product is methanol, and the leaving group is bromine.
Hi everyone, my name is Muhammad Fadi Iman bin Muhammad Fadal. My metric number is 221553. Today I want to share about the real life application of addition process in organic chemistry. It is about the process of turning vegetable oil into margarine. Margarine is made by a process called hydrogenation of vegetable oils. It includes the addition of hydrogens to the double bonds in unsaturated fatty acids, using hydrogen gas and nickels as the catalyzer. Usually, unsaturated fatty acids tends to be in liquid in room temperature. With the addition of hydrogen atoms into the double bonds, it increases the melting point of the compound and makes it a solid at room temperature. And there goes our margarine. However, there are some probable health risks from eating hydrogenated fats or oils. The double bonds in unsaturated fats and oils tend to have the groups around them arranged in the cis form. The relatively high temperatures used in the hydrogenation process tend to flip some of the carbon-to-carbon double bonds into the trans form, present in the final margarine in molecules of trans fats. The consumption of trans fats has been shown to increase cholesterol levels, leading to an increased risk of heart disease. And there is our example of addition process in real life application. Thank you.
Assalamualaikum and hi sir. My name is Nasihah with my metric number is 2315258 and I'm the first presenter of group 3. We will present to you about concept of reaction and real life application. In the concept reaction, we have a tree which is addition, elimination and substitution. Addition reaction occur when two or more reactors combine to form one single product. In the product, we contain all the atoms that were present in the reactants. So addition reaction only occur to unsaturated carbon, which is alkene and alkyne. So this example, 1 plus B equal to C. This is like one product on. So in the addition, we have 5 reactions, which is halogenation, hydrogenation, and polymerization. So I will present about halogenation. Halogenation involves when the addition of hydrogen atom and the halogen atom to an unsaturated carbon, which is alkene and alkyne. So an example of halogen atom or S is fluorine, chlorine, bromine, and iodine. Here's the example, the hydrohalogenation of ethane to the haloethane. We can see that ethane plus the HX, which is hydrohalogenation, and to form the haloethane. And this we can also see that a double bond to the single bond, which is a double bond ethane to the single bond to form the haloethane. If we have a two product, we can classify it into a two, which is a major product or minor product. For major product, we do that hydrogen atom is added to this substituent of carbon atom, which will like the carbon atom with the least number of carbon atoms bonded onto it. So for the hydrogen atom, it's added to the more substituent carbon atom, which is a carbon atom with the most number of carbon atoms bonded to it. For example, the hydrohalogenation of 2-methylpropane to form 2-fluoro-2-methylpropane, which is our major product, and 1-fluoro-2-methylpropane is our primary product. So in major product, we can see that our fluorine atom bonded to 3 carbon atoms, while our halogen bonded to only 1 carbon atoms. In binary product, we can see that they are vice versa, which is our halogen atoms bonded to 3 carbon atoms, while our fluorine atoms bonded to 1 carbon atoms.
Assalamualaikum, my name is Aini binti Jamian. I will explain about halogenation and hydration. Halogenation is very similar to hydrohalogenation, but a diatomic halogen molecule is added across the double bond. Diatomic halogen molecule, which is Br2, Cl2, F2 and I2. So the example of halogenation is the reaction between Br2 plus ethene. So it will form 1,2-dibromoethane. So the next one is hydration. A hydration reaction involves the addition of water, which is H2O, to an unsaturated compound. This is one way of preparing alcohol from the corresponding alkene. So the example of hydration is ethene plus H2O. It will form ethanol. So if more than one product is possible, we can differentiate it between major and minor product. So major product will be the compound where the hydrogen atom is added to the least substituted carbon atom, and the hydroxyl and ion is added to the most substituted carbon atom. So as we can see at the example is 2-methylpropane-2-ol will be the major product because OH- is attached to the tertiary carbon, which is the carbon is attached to the another 3 carbon, and the hydrogen atom is attached to the primary carbon, which is the carbon only attached to the 1 carbon. So it will be major product, and minor product for this example is 2-methylpropan-1-ol. So lastly, the reaction condition for hydration is water must be present in excess, and acid catalyst is needed for this reaction to take place, and most commonly used is phosphoric acid, which is H3PO4. So that's all from me.
My name is Iffah binti Sham. My metric number is 2313734. So another type of addition reaction is hydrogenation. Hydrogenation is a chemical reaction which hydrogen atoms are added to another compound. It involves the addition of hydrogen to unsaturated compound like alkenes and alkynes to produce saturated compound, for example, alkanes. The double bond is broken and more hydrogen atoms are added to the molecule. During hydrogenation, the unsaturated compound reacts with molecular hydrogen. The double and triple bond in the unsaturated compound breaks, and hydrogen atoms are added to carbon atoms, resulting in formation of saturated compounds. The reaction condition of hydrogenation is catalyst is needed. Catalysts such as nickel, palladium and platinum. It helps lower the activation energy of the reaction, making it proceed at a faster rate. Heating is also required because it promotes the reaction and enhances the efficiency of hydrogenation. Hydrogenation must be done under an inert atmosphere, not air. You can see from the example of hydrogenation of vegetable oil to margarine. And last is a polymerization reaction. A polymer is made up of smaller units called monomer. Monomers are added together and it will be forming a polymer. It occurs through addition reaction. You can see from the graph.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqbal Hakimi bin Aslan. My metric number is 2314483. So I'm going to explain about elimination reaction. An elimination reaction occurs when atoms from an organic molecule are removed, causing a double bond to form. Reactant is broken up into two products. Other than that, elimination reaction is the reverse process of the addition reaction. Elimination reaction occur with saturated compound, which means the compound only have single bond. The general equation for an elimination reaction is A equal to B plus C. So for elimination reaction, there are two groups that involve, which is alkyl halide and alcohol. For alkyl halide, the reaction is called dehydrohalogenation. In dehydrohalogenation, alkyl halides can undergo elimination reaction when heated in the presence of strong base, for example, calcium hydroxide. The base then helps the elimination of the halogen and a hydrogen atom. For example, dehydrohalogenation of chloropropane in the presence of natrium hydroxide in the state of heated to form propene and HCl. Notice that propene have double bond and HCl is originally from chloropropane. Then for alcohol, the reaction is called dehydration of alcohol. Alcohol can undergo elimination reaction when the alcohol is heated in the presence of strong acid, for example HCl. During the dehydration of an alcohol, the hydroxyl group, which is OH, and a hydrogen atom are eliminated from the reactant. A molecule of water is formed as a product in the reaction along with an alkene. Okay, for example, we have put 2-ol. In the presence of nitric acid, produce put-2-in or put-1-in, an addition of a water molecule, which put-2-in is the major product and put-1-in is the minor product.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Kamarul bin Kamarul Zaman. My metric number is 2315909. So today I'm gonna explain about the substitution reaction. So substitution reaction is a reaction where one functional group is replaced by another one functional group. So for the first reaction is the formation of haloalkenes. So haloalkene can be formed when the hydroxyl OH group be replaced by the halogen atom, for example iodine, chlorine, fluorine and bromine. And this work the best with the tertiary alcohol. So for example, we have 2-methyl, 2-propanol, and we react with hydrochloric acid, so it will become 2-chloro 2-methyl propane plus water. So the OH group from the alcohol will replace by each other of a chlorine atom, so it will become haloalkene and also water. So what about primary and secondary alcohol? They also can undergo the substitution reaction, but it requires a very high temperature and a very slow reaction. So for the second reaction, we have hydrolysis, which is the water breakdown. So we are using water to break down the haloalkene to produce alcohol. So for example, we have chloroethane. When we react with the water, we are going to get ethanol plus hydrochloric acid. So the molecule, the chlorine atom will replace the OH group from the water, so become a hydrochloric acid, where the OH hydroxy group will replace the Cl group and become the alcohol compound. So we also can use a base that dissolve in the water to undergo the hydrolysis reaction. But we have to follow a certain condition, which is 3 condition, which is low temperature around the room temperature, dilute solution of a strong base, which is for example sodium hydroxide, and also the solution must be in aqueous state, which is dissolved in the water. So if we fulfill these 3 conditions, we can use a base that dissolves in the water to undergo hydrolysis reaction. But we have to remind ourselves, if the concentration of the base is too high, then the halogen atom and also a hydrogen atom could be eliminated in the process of dehydrohalogenation. That's all from me. Thank you.
Assalamualaikum. My name is Khalish. My metric number is 2316205, and today I will be telling you about substitution reaction. The first thing is substitution of alkene. So alkene can undergo substitution reaction when considerable amounts of energy, such as UV light, The substitution reaction with alkene are not too useful because the end result contains a mixture of different products. So for example here, we have methane and we want it to react with bromine. We cannot react it just like that, thus we need to have a catalyst such as UV light to enhance it to be a substitution reaction. So when we add UV light, the end product will be 1 bromomethane plus excess of HBr. So next one is the substitution of aromatic compound. So aromatic compound will undergo substitution reaction with Cl2 or Br2 only in the presence of a catalyst. So for example, we have a benzene and we want it to react with bromine. We cannot react it just like that because the benzene is condensed. So we need a catalyst. So what we have as a catalyst is FeBr2. So when we react it with FeBr2, the H from the benzene will undergo substitution and take one of the benzene together and with excess of HBr. So that's it for me. Thank you and Assalamualaikum warahmatullahi wabarakatuh.
Hi, my name is Amirrul Aziz. My metric number is 2312179. I'm gonna explain about real life event. I chose elimination reaction as my example. So in this example, I choose formaldehyde formation, which is formaldehyde formation we get from a methanol compound. So formaldehyde is a main constituent for manufacturing chemicals such as melamine, urea, and phenolic resin. It is available in 37% aqueous. It is identified by some of its properties like the molecular weight about 30.3, boiling point at 118 degrees Celsius, melting point at 19 degrees Celsius. So basically the process that we need is dehydrogenation. When we talk about dehydrogenation, the one thing that comes out of my mind is basically the removal of hydrogen gas from a methanol compound. So in this equation, in this diagram, I show you about how it works. Hydrogen in the methanol, we separated it and we get formaldehyde from. So this is the one of the elimination reaction. So this is the machine in manufacturing formaldehyde. In this reaction, we normally use catalyst, copper oxide and zinc oxide as a catalyst, and we use the temperature about 200 to 300 degrees Celsius and at a control pressure. So when we get formaldehyde mixture in the last stage, we get a formaldehyde mixture with other compound in it. So we need to separate it by distillation process. So the application for the formaldehyde is it used in production of resin such as urea formaldehyde and phenol formaldehyde resin, which are essential in the manufacture of polywood, particle board, and the other wood product. So it is also the key component in the production of various polymers and plastic. Formaldehyde-based solutions such as formalin are used in disinfectant and preservative. Employed in the synthesis of pharmaceutical and other chemicals also need formaldehyde. That's all.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ammar Berzaimi. My metric number is 2313151. From Group 4, we are going to make a video presentation about the 3 chemical reactions in organic chemistry, which includes the addition, elimination, and substitution reaction. For the addition reaction, it is simple meaning. It means we added something into an empty space. So to make this happen, we should have the unsaturated hydrocarbon, because we know if ethene, we have the 2 empty space there. So the addition reaction could happen. So for the addition reaction, we have 2 types, which is polar and non-polar. In polar, we can classify into two, which is electrophilic addition and nucleophilic addition. In both of them have the something called electrophile and nucleophile. So electrophile means the electron deficient, which loves the electron, while nucleophile is the other way around. It is an electron rich and loves the nucleus. So let's go to the electrophilic addition first. So for example, the electrophilic addition, this is the reaction mechanism. We take ethene as an example and react it with hydrogen bromide. So at the hydrogen bromide, we know that the bromine is partially negative because it is more electronegative than hydrogen, so it will withdraw the electron towards itself, and the hydrogen then become the electrophile because it is an electron division. And then from ethene they will donate two lone pairs to the hydrogen, and then will result the hydrogen will attach the one carbon there, and then the other one carbon will be the electron division next. So the bromide ion will donate the lone pair to the carbon, so as a result it will produce bromethane. So the second one is the nucleophilic addition. So in nucleophilic addition, we have something called nucleophile, which is the nucleus loving. It is an electron rich. So in nucleophilic addition, it is more commonly happen to the carbonyl group, which is aldehyde and ketones. In the reaction mechanism, we have three steps. So the first step is to generate a nucleophile. So if we want to generate this nucleophile, it is a method. If you want to using a trace NaO or trace NaCN. So if we want to do a trace NaO, we should the first step is to react the NaO with the HCN first. It will produce Na plus Cn minus, and then plus with H2O. So the nucleophile is a Cn minus. The second step is the nucleophilic attack. So let's take the aldehyde as an example. We know that carbon is more electropositive than the oxygen, and the oxygen is more electronegative. Then the nucleophile will attack the carbon, and it will form the carbon-carbon bond there. The electron from the carbon oxygen will go to the oxygen because the pi bond will break. Okay, and then that is our slow reaction, and that is not very stable because the oxygen is negatively charged there. So it will prompt us to the next step, which is the protonation plus regenerate the catalyst. I said before, oxygen is highly unstable because it have the minus there. So what it will do, it will steal the hydrogen from the HCN, which is the reactant in this reaction. So hydrogen is the partially positive than the cyanide ion. And then this is a first step reaction because why? The oxygen is highly unstable, so it will trigger this protonation very readily. So then the oxygen and hydrogen will form a bond there. So lastly, we will end up having a cyanohydrin with the cyanide ion Cn minus, which is the catalyst.
My name is Putri Zurina Zaida binti Zaini, and my metric number is 2315964. What is nonpolar addition reaction? Non-polar addition reaction have radical intermediates or mechanism that means no intermediate in the reaction. There are three types of non-polar addition reaction, which are free radical addition, addition polymerization, and cycloaddition reaction. So firstly, we have free radical addition. This addition have a radical intermediate in the reaction mechanism. So for instance, hydrohalogenation of alkene in presence of hydrogen halide and peroxide is free radical reaction. So first step, in this reaction, HBr will react with peroxide to form bromine radical, and then bromine radical add to the alkene to form carbon radical intermediate. And the last step, radical intermediate takes hydrogen to give addition product. Secondly, we have addition polymerization. It is basically a free radical addition, but the difference is here is large amount of monomer gets added in the chain to form polymer compounds. As for example, synthesis of polyvinyl chloride (PVC) from vinyl chloride is an addition polymerization reaction, and this is how it occurs. And lastly, for non-polar addition reaction, we have cycloaddition reaction. Cycloaddition reaction does not have any intermediates in reaction mechanism. For example, is diels-alder reaction is 4 plus 2 cycloaddition reaction. Here, 2,4-diene reacts with alkene or a dienophile to form a 6-number cyclic ring. And this is how it occurs. So that's all for addition reaction.
My name is Iman bin Anuar. Elimination reaction is a type of organic reaction in which two substituents are removed from a molecule to form a new product. The process takes place in the presence of acid, base, metal, sometimes through heating. Elimination reaction is generally catalyzed by a metal, an acid, or the base. So the purpose of the elimination reaction is to produce organic compound containing double or triple carbon bond, such as alkene and alkyne. The mechanism of elimination reaction: first, the removal of proton, which is the hydrogen from the organic compound is removed, called deprotonation. Then the compound from the chemical double bond, then the breaking of the bond to the leaving group. In this case, X is the leaving group. There are two types of elimination reaction, E1 and E2. E1 is the two-step mechanism. E2 is one-step mechanism. E2 is also known as bimolecular second-order reaction. E1 unimolecular first-order reaction. E1 is only applied successful after the reaction. E1 and E2 are differ in the order and the rate of the breaking and forming bond. According to the Syasya, the alkene formed in the greatest amount is the one that corresponds to the removal of the hydrogen from beta carbon having the previous hydrogen substitute. What is meant by him is the major product is determined by how many alkyl group is formed. So, the more alkyl group attached to the carbon-carbon double bond, the compound will be the major and vice versa. Zafri states that the major product is that alkene which has greater number of alkyl group attached to the double bonded carbon atoms. So in this figure, put 2 in is the major because have 2 alkyl group attached to the C double bond C. B, put 1 in is the minor product because of only have 1 alkyl group attached to the C double bond C. For your information, alpha carbon is the carbon attached to the leaving group, ER in this case. The carbon adjacent to the alpha carbon is the beta carbon.
My name is Syasya Iman and today I want to talk about the example for elimination both for E1 and E2. So here we go first for the E1 example. In this example, we'll be using the dehydration of ethanols to become ethenes because in this reaction it will require the mechanism for elimination in order for ethanol to become ethenes. So here is the following steps that requires in the elimination mechanism. So here for the step 1, the ethanols will undergo protonations resulting in the formation of a positively charged species called a carbonation. The protonation steps often initiated by the presence of an acid such as sulfuric acid because we need the hydrogen ion from it to form a bond with the hydroxyl group from the alcohol. So here, as you can see, after they form a bond between the oxygen and hydrogen, the oxygen will become positively charged because it lost its electron, and here the alcohol will become protonates because of the new formations. Alright, moving on to the step 2, which is the formation of carbonation. Here the water molecules that exist here is unstable due to the oxygen has positively charged in it. So in order for the oxygen to remove its positively charge, it requires 1 electron for the carbon to remove the positive charge. So since the carbon is more electropositive than the oxygen, the carbon will give 1 electron to the oxygen, and because of this, it will break the bond between the carbon and the water molecules. So here, as you can see, the carbon here has positively charged because it lost its 1 electron to the oxygen. So because of this, the carbon with the positively charged is what we call the carbonation. So here, the final step for this mechanism, the carbon with positively charged here is unstable and needs to form bonds with another element. But the hydrogen here cannot form any more bond with carbon, and the only suitable candidates for it is the next carbon with it. But in order for the carbon to make new bond, the carbon here must have negatively charged in it since negative and positive attract each other. So in order for this carbons to become negatively charged, it need to remove 1 hydrogen from it. Because here the hydrogen is more electropositive than the carbon, it will lose its 1 electron to the carbon. So because of this, the hydrogen, the bond between the carbon and hydrogen will break, and the carbon will left with negatively charged while the hydrogen will left with the positively charged. So here, after the carbon become negatively charged, it can mix new bond with the carbon with positively charged to form a new bond, and here, as you can see, it forms new double bond here and becomes ethene. So for this reaction, reaction, we will be using the hydrohalogenation reaction of two bromobutane to form one butane or two butanes. So here, in order for this reaction occur, we must mix the two bromobutane with any strong base such as sodium hydroxide, because we need the hydroxide ion from it to remove hydrogen from the carbon. So here, as you can see, the hydroxide ion remove the hydrogen from carbon 2 in order for it to become water. So because of the hydrogen wants to break the bonds with the carbon, the hydrogen needs to give one electron to the carbon, since carbon is more electronegative than it. So after it breaks bond between it, the hydrogen with positive charge will mix with the hydroxide ion to form water, while carbon here will have negatively charged in it. So the carbon with negatively charged here is unstable, and it needs to form a new bonds with any carbon with positively charged. So here, the carbon that has 3 hydrogen attached in it cannot have carbon with positive charge, but carbon that has bond between the bromine can form positively charged, because bromine is more electronegative than carbon. So in order here for the carbon to break a bond between carbon and bromine, the carbon needs to give one electron to the bromine, since bromine is more electronegative than carbon. So after the carbon give one electron to the bromine, it will break the bond between them, and the carbon here will become positively charged, while the bromine here will be negatively charged. So bromine here with positively charged can now make new bond with the carbon with negatively charged. Here, as you can see, there is boot 2 in and boot 1 in. The new double bond here is result from the carbon negatively charged and the carbon with positively charged. But as you can see here, according to the Zeiss-Tiff rule, the boot 2 in is a major product, while the boot 1 in is minor product for this process.
My name is Iman bin Ahmed Rizal, and my metric number is 2312945. There are 3 types of substitution reactions. So firstly, we have the electrophilic substitution, we have the nucleophilic substitution, and finally the radical substitution. So in electrophilic substitution, usually we will replace a compound or an element with an electrophile. And then in nucleophilic substitution, we will replace it with a nucleophile. And then finally, for the radical substitution, usually we will use a compound that has radical. So in this case, the chlorine molecule will separate into 2 radicals, which then will react with the compound. The general mechanisms of electrophilic substitution. Okay, so if we look at here, we will have an electrophile. In this case, this electrophile is E. As you can see, it has a positive charge. So the mechanism goes like this. The pi bond from the benzene will go out to react with the electrophile, and then forming a bond. After that, the spectator ion will take the electron from the hydrogen, and then the bond from the hydrogen carbon will go back into the benzene to form a double bond, a pi bond. So that makes the electrophilic aromatic product. Nucleophilic substitution general mechanisms. So in nucleophilic, we have SN1 and SN2. SN here means the first order nucleophilic substitution and the second order nucleophilic substitution. So if we look at here, the general mechanisms goes like this. The leaving group will leave and form an ionization and form an ion here. And then another ion will come in to react with the carbocation intermediate. The nucleophile here will is negative charge, and then the final product will produce. In this one, the reaction goes all at once in one go. That means when the nucleophilic attacks here, the carbon here will ionize, and then this one will become the nucleophilic. It happens all at once. This is the intermediate. As you can see, it has a partial bond here and partial bond here, and then this one will break and this one will form. So as you can see, it formed the final product. In radical substitution, we usually have a compound that is needing initiation process. So in the initiation process, it means that they will form a free radical. So as you can see, the chlorine molecule here, one electron will go to each chlorine, forming a free radical. And then in the step 2, now we will use the compound that will react with the radical. So what happens is the radical attacks the hydrogen here, replacing it, and then forming a radical, and then forming this other compound. The radical of the methane here now will react with another chlorine molecule, which form a metal chloride, and then another chlorine free radical. So the leftover radicals will form the chlorine molecule again, and this one will form another product. We have the substitution reactions of the nucleophilic SN1 and SN2. So first of all, we will look at the SN1, SN2 I mean. This one has only one intermediate, but it is not shown here, but it has only one intermediate. Of course, we have nucleophile here. The nucleophile will attack the carbon atom, and then the bond forming the carbon atom and the other nucleophile will break. This one will ionize, become a chlorine ion, and then the bromine will form the bond here. So now it becomes a bromide, a metal bromide. So in nucleophilic SN2, it requires a strong nucleophile. Meanwhile, in SN1, it only requires a neutral or a weak nucleophile. So next up, we will look at the this SN1 reaction. So in the SN1 substitution, we have two intermediate. The leaving group will leave, meaning that this one will ionize. The electron here will form the ion for the bromine. As you can see here, the bromine ion. And then what happens next is we will be left with the carbocation intermediate. This intermediate will be attacked by the nucleophile, the other nucleophile. So this nucleophile will attack the carbocation. So what happens then is it will form the product. So in SN1, it is a two-step mechanism, but in SN2, it is only a one-step mechanism. And in SN2, there is no carbocation form, but in SN1, there is a carbocation form.
My name is Sarah Humaira and my matrix number is 2311448. For SN1, I'll be using the example of third butyl bromide. As we know, SN1 is a two-step mechanism where the first step is the bond breaking to form carbocation, and the second step is the nucleophile attack, followed with bond formation. So for the first step, the bromide anions separate themselves from the third butyl bromide, which results in the third butyl carbocation and bromide ion. Then the second step is where the water molecule, which is a weak nucleophile, attacks the carbocation, which forms ozonium ion intermediate. Then followed by the bond formation, where a second water molecule, which acts as the base, attacks the ozonium ion and forms the butyl alcohol and hydronium ion. The nucleophile attack in SN1 can occur from either side, which is 180 degrees away from the halide group, which formed an inversion or the major product, or at the same location of the halide group that form a retention or the minor product. Next is the example of SN2, which is a one-step mechanism. Here the sodium hydroxide, which is a strong nucleophile, attacks the carbon atom of ethyl chloride, which forms carbon ion and sodium ion. Then followed by the bond breaking of the carbon-chlorine bond that takes place immediately results in ethanol and sodium chloride. The nucleophile attack through the backside attack, which is 180 degrees away from the halide group, which produces a product with an inversion configuration only.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sabrina Alia binti Ali. My metric number is 2313278, and I'll be sharing with you the real-life application of addition reaction. Have you ever consumed bread and margarine as a breakfast? And have you ever wondered how do we get our margarine? So it is all with the help of addition reactions. To explain, vegetable oil is actually a polyunsaturated fat, which means it has many carbon-carbon double bonds within its structure. Now, these fats are normally in a liquid state when in room temperature. So when we hydrogenate or add hydrogen to this carbon-carbon double bond, which is bypassing hydrogen gas over these molecules in the presence of the catalyst platinum at the temperature of 60 degrees Celsius, we will get hydrogenated reaction. So after this reaction, the fats will be hardened, which hydrogenated fats, they will have higher melting point. So which explains why they are in solid state in room temperature. So that is why when we buy our margarine, we will get a solid margarine in the container. But the real question is, why is it that in the container our margarine are in solid state, but it's softer when it's being spread on the bread? So to explain, this happens because the double bonds in the polyunsaturated vegetable oils are hydrogenated partially, not totally.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Roshada Miroflan. My matric number 2312961. I'm from Chemical Engineering and Organic Chemistry, Section 1, Group 65. Okay, today I want to explain to you guys about elimination reaction. In general, elimination means we eliminate something from their for a certain part. But in organic chemistry, elimination reaction is a type of organic reaction which two substituents will be eliminated from a molecule. And another meaning, the elimination reaction is to convert saturated compound to unsaturated compound. In easy way, we can define that we will convert single bond structure to double bond structure. Okay. Then in elimination reaction we will have E1 and E2. But I will explain the E1, which is unimolecule elimination reaction. Why it called E1? Because E determined for elimination, and 1 is because in this elimination reaction, rate determining step only involved in one molecule. Okay, now we will go to the reaction and mechanism in E1 and E1. For reaction, our molecule will react with the weak base. For example, ethanol, methanol. Now, I have some example. CH3, 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 C and bromine. Our bromine is our alkyl. Okay. For example, this molecule will react with methanol. For the first one, we will eliminate the bromine. We eliminate the bromine, and then the bromine will become ion bromide, which means we have. Now we will go to reaction and mechanism in E1. For the reaction, our molecule, our saturated molecule will react with base. For example, ethanol and methanol. So I have some example, which is CH3, CH3, CH3 and CBr. We react with the methanol, our weak base. The first one, we will eliminate our bromine. So why we will eliminate the bromine? Because bromine has more electron negative. So we will leave the bromine will lift this component, and it called the leaving group. So our bromine will become ion bromide. Then our carbon here will become have one electron here, because the bond between this carbon and bromine will have eliminate. That's why they have one electron here and one electron for ion bromide. Okay. For this carbon, I will say as alpha carbon, because this carbon attached with our bromine, and this carbon I will call as our beta carbon. Then when we have eliminated the bromine, we will go to our methanol. Our OH here will react with this beta carbon, to cancel out one of the hydrogen in beta carbon. This is a structure that reaction between our OH and our beta hydrogen in beta carbon. Now our CH2 will have extra electron, and this extra electron will react with this electron to make one extra bond in here. That's why we will get the unsaturated double bond. So I will write the full reaction, which is we will get our CH3, and this will be a double bond because this electron and this electron react CH2. Now we have our unsaturated structure. Then we have our bromine, ion bromine, and finally our H2O from our reaction between OH and our beta carbon. Then we look at a mechanism for in E1. We have two mechanisms. The first one, formation of carbocation ion, and the second one, attack of nucleophile. Now we look for the first one, formation of carbocation ion. This called formation of carbon because at the final result we will get a carbon cation structure. How we can get a carbon cation structure? I write again the original structure. This is 3. As I said, the first one, we will eliminate this Br from this molecule. Every minute we will get iron bromide. Then eliminate because this bromine is more electronegative. That's why we'll leave this molecule and become a living group. And then when this bromine eliminate at our carbon, we will have one extra electron, and this one extra electron is called carbon cation. That's why this molecule we will call the carbon cation. And then we will look at the final one. We will look at the attack of nucleophile. The nucleophile here is come from our methanol, which means OH. This OH, our OH minus, will react with this with our carbon cation here plus. React with our carbon cation. This OH will react with one H from this carbon, and this will get our H2O because we have two H and one oxygen. Okay. Then when this happen, our carbon here we have extra electron. For example, we have this extra electron, and this extra electron we react with this extra electron at this carbon. We make one single bond here, which means they have double bond between this carbon. That's how our final answer will be unsaturated molecule. I think that's all from me. Now we will look at E2 reaction.
Assalamualaikum warahmatullahi wabarakatuh, and a very good evening to all. My name is Adam Haika from Group 5, and I will be explaining further about E2, where E2 also is also an elimination reaction, which also convert from saturated to unsaturated, which is from some single bond to the double bond. But it will only involve of primary alkyl halides, which means that it's of CH2 with only react with the one only carbon, and then it also use strong base. If, for example, alcoholic KOH, or maybe alcoholic NaOH. As why? It is to pull the hydrogen easily. So for the reaction method, we can see that from the alcoholic KOH, it will react with the substance which is this one, and from the K, it will eliminate the X from the molecule, and it will perform KX. And furthermore, from the OH himself, it will react with the H2S because it has eliminated this X, which causing it to make it adding a new electron, and which is from the new electron So from the E2 of the reaction, we'll see a molecule here I've drawn, we're gonna classify this as the B beta carbon because it doesn't attach to any alkyl halide. Why is this one is alpha carbon because it is attached with the alkyl halides. So from the molecule will react with the alcoholic KOH, causing the KOH here to react with the X and to form a KX while the X is eliminated from the molecule here. It will form from the alpha carbon. It will form a new electron and adding a new electron, and then from the OH himself of the base, it will react with the other beta carbon, and then it will form a water here later, causing the beta carbon to form plus electron as well. And from the remaining of beta carbon and alpha carbon, it also both of them have a separate new electron, which causing it to have the double bond here. The mechanism, we can clearly see that it is actually a nucleophile which provided by the strong base as for example the alcoholic KOH. So the OH minus will react with this molecule of, to be exact, from the beta carbon, and the CH2 here will eliminate the X, causing it to have the added electron, and also from here we have also eliminate one of the H to react with OH minus here, and also it is we will be forming a double bond here because it is have one additional electron and also here one additional electron, causing it to the final formation is CH3 CH CH2 and here is double bond plus with KX and also the H2O. So that's all from me from the E2 elimination. Thank you. So from the elimination reaction, we can also make an application on ourselves in our daily life. For example, problem solving. So as we all know that elimination reaction is actually required careful condition and mechanism whereby our own self we can applicate those elimination in eliminating obstacle or even in needed elements to achieve our own desired outcome. So furthermore, we can also interpret it as a learning and education, where as we all know that elimination required involve breaking and forming bonds to create a new product. Same as our own daily life as a student, we also can discarding outdated information or concepts and we can displace it with a new knowledge that could help in our future. So that's all from us. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So today I will explain about substitution reaction. So the definition, substitution reaction is a chemical reaction where an atom or a group of atoms in a molecule is replaced by another atom or group of atoms. This typically involves a reactant replacing an existing part of a molecule, resulting in the formation of a new compound. Common types include, which is two, nucleophilic and electrophilic substitution. So I give you one example for the basic substitution reaction. So this is the reaction. Okay, you can see that chlorine of methane. In this reaction, a hydrogen in the methane is a substitute with chlorine. Will substitute with chlorine atom producing chloromethane and hydrochloric acid. So this is the example. CH4 plus Cl2
and it will produce CH3Cl plus hydrochloric acid, which is HCl. So the next part is I will explain about the nucleophilic. Will present the nucleophilic substitution. So nucleophilic substitution is a chemical reaction where an electron reach nucleophile, which is substance that have a lone pair, like that lone pair, reacts with an electron division substrate, resulting in the replacement of one group with the nucleophile. So the example for the reaction is alkyl halide. So this you can see that our reaction as the hydroxide we produce it was the hydroxide we substitute with the Cl, which is we produce ROH plus Cl minus. We can see that the OH is the nucleophile, which is the electron rich nucleophile, which is the substance has a rich electron, and the RCl is the substrate, and this is the product, and Cl will be the leaving group. So the next part is substitution nucleophilic. There has a two, which is unimolecular and where substitution nucleophilic bimolecular. So this one is in substitution nucleophilic unimolecular. The rate determining steps involves the dissociation of this substrate into a carbon cation, intermediate, and a leaving group. The nucleophile then attacks the carbon cation, leading to the formation of this substitution product. I can be the same with this example. Substitution nucleophilic unimolecular reaction are characterized by the involvement of a two-step mechanism and are often favored in situations where the stability of the carbon cation is crucial. So the next one is substitution nucleophilic bimolecular. In substitution nucleophilic bimolecular, the nucleophile directly attacks the substrate, while the leaving group is simultaneously expelled. This reaction proceeds through a single constant step, where the nucleophile and the leaving group are involved in the transition state. The rate of a substitution nucleophilic bimolecular reaction is influenced by both the concentration of the nucleophile and the substrate. So it will depend on the concentration of the host substance, and that determine the transition state. So and the last one is the overview of the both unimolecular and bimolecular substitution reaction. So factors influencing the choice between substitution nucleophilic unimolecular and substitution nucleophilic bimolecular mechanism include the nature of the substrate, the strength of the nucleophile, and the steric hindrance around the reacting carbon atom. So by understanding the social condition and characteristic of the reactants, allows chemists to predict the outcome of the nucleophilic substitution reaction. So we need to determine the condition and the characteristic of the reactants, and then we will know the outcome of the nucleophilic substitution reaction. So that's all from me. Thank you. Sorry for the unclear vision, so I will explain again for the nucleophilic solution chemical. I will explain the example. So this is the example, which is alkyl halide. You can see that the RCl, we can see the RCl is the substrate and reacts with the nucleophile, which is hydroxide OH minus. You produce OH plus Cl minus, and RH is the product of the substitution, and Sem1 is the living group. Sorry for the unclear vision.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq bin Saifullah and my metric number is 2219533. I will presenting about electrophilic substitution reaction. An electrophilic substitution reaction is a chemical reaction in which the functional group attached to a compound is replaced by an electrophile. The displaced functional group is typically a hydrogen atom. Types of electrophilic substitution is divided by two types, which is the first one is electrophilic aromatic substitution reaction, and the second one is electrophilic aliphatic substitution reaction. Next is electrophilic aromatic substitution reaction. Electrophilic aromatic substitution reactions are organic reactions wherein an electrophile replaces an atom which is attached to an aromatic ring. Commonly, this reaction involves the replacement of a hydrogen atom which is belonging to a benzene ring with an electrophile. Example that can relate with electrophilic aromatic substitution reaction is aromatic halogenation reactions. Halogenation is a type of a substitution reaction where hydrogen is replaced with bromine or chlorine. The process, which is called chlorination or bromination, make use of a Lewis acid which take a pair of electrons to form a permanent bond dipole in the Cl-Cl bond or Br bond. The bromine or chlorine has a formal positive charge due to the dipole, making the group electrophilic enough to easily overcome the activation energy which is generated due to the loss of aromaticity of the benzene ring, which is we can see as the picture show. Next, I will talk about the second type of electrophilic substitution reaction, which is electrophilic aliphatic substitution reaction. In electrophilic aliphatic substitution reactions, an electrophile replaces the functional group, which is generally hydrogen, in an aliphatic compound. This reaction can be classified into the following 5 steps. The first one is halogenation of ketones. The second one is nitrosation. The third one is ketoenol tautomerism. The fourth one is insertion of a carbene into a carbon hydrogen bond. The last one is diazonium coupling, which is aliphatic. This electrophilic substitution reaction can result in an inversion of configuration if the electrophilic attack occurs at an angle of 180 degrees to the leaving group, which is attacked from the rear. For the next part, we will talk about mechanism of electrophilic substitution reaction. The electrophilic substitution reaction mechanism involves 3 steps. Steps 1 is generation of electrophile. For example, anhydrous aluminum chloride is a very useful Lewis acid in the generation of electrophile from the chlorination, alkylation, and acylation of an aromatic ring. The resulting electrophiles, which is from the combination of anhydrous aluminum chloride and the attacking reagent, which are Cl+, R+, and Rc plus O respectively, as shown as the figure below. For steps 2, mechanism of electrophilic substitution reaction is formation of carbocation. The electrophile attacks the aromatic ring, forming a sigma complex or an aranium ion. One of the carbon in this aranium ion is sp3 hybridized, as it shows on the picture. This aranium ion finds stability in a resonance structure Since the delocalization of electrons stops at the sp3 hybridized carbon, the sigma complex or the rhenium ion loses its aromatic character, which is we can see on the picture shown. For the last steps of mechanism of electrophilic substitution reaction is removal of proton. In order to restore the aromatic character, the sigma complex releases a proton from the sp3 hybridized carbon when it is attacked by the tetrachloroaluminates ion. The reaction describing the removal of a proton from the sigma complex as it shows on the picture below. Thus, the electrophile replaces the hydrogen atom in the benzene ring. The electrophilic substitution reaction is a very important reaction in organic chemistry as the concept is used in many organic name reaction. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nasihah binti Warisdi. So today I'm going to explain to you about the addition reaction. First of all, what is addition reaction? Addition reaction is when we add atom or group of atom to a molecule with multiple bonds. This reaction involves breaking one pi bond in order to form two sigma bond and usually occurs in the presence of catalyst. So generally, we will add halogen, water or halogen into the molecule. As for my part, I'm going to explain about the halohydrine formation. The halo comes from halogen and hydrine comes from water. Think of hydration. So we will answer these three questions in halohydrine formation, which is first question, what are we adding across the double bond? Second, where will the group add, also known as radioselectivity? Lastly, what is the expected stereochemistry of the added group? So for question number 1, we will add chlorine or bromine across the double bond just in a solvent like water. As you guys can see, when Z3-methylpent2ene react with chlorine in a solvent like water, which is also a nucleophile, we will get chlorohydrine as our final product. So I'm going to explain to you how we will get this final product. First, the nucleophilic alkene will attack chlorine. Then chloronium ion will form to stabilize the positive charge. Okay, stereochemically speaking, the chloronium bridge can be sticking up or down, which ultimately means that we will get these two enantiomer react with water to form our final product. This concept basically known as a racemic mixture. Now, for question number 2, the next step in halohydrine formation is we will have a water molecule as our nucleophilic attacker. So oxygen's lone pair will attack at the site where we can draw a carbocation that contributes more to the resonance hybrid, which is tertiary one. So we will expect water to add to the more substitute side of the bond, and this reaction is radioselective. For question number 3, the chloronium ion blocks syn addition, so the water adds anti. And then a second water molecule will deprotonate the oxonomium ion, forming an alcohol group in our final product. They are called chlorohydrine because this is a halohydrine formation reaction. That's all from me. Thank you.
My name is Sofia binti Badul Hisham. My metric number is 2315990. So I will explain another example of addition reaction, which is hydrations of alkene. In general, the hydrations of alkene involves adding water across the double bond of alkene, leading to the formations of alcohol. This reaction typically occurs in the presence of an acid catalyst. As you can see on the slides, there are 3 key questions that we will get the answer throughout my explanation. So let's discuss about hydration in further detail. So next, we'll move to the mechanism of how alkene hydration happens. There are 3 steps. The first one is initiation. In the first diagram, we have a methyl cyclohexane with an acid catalyst. The nucleophilic pi electron where the double bond are will reach out and grab the hydrogen, causing the electron between the hydrogen and oxygen to collapse onto the oxygen. Then it will form a tertiary carbocation with a hydrogen. The second step is nucleophilic attack. Another water molecule will reach out with its lone pair of electrons and attack carbocation, giving us the oxonium intermediate. The third step is deprotonation. Another water molecule in the solution will reach out and grab that extra hydrogen, giving oxygen back its lone pair of electrons. This will give us the final product where the alcohol is placed on the most substituted carbon and the hydronium ion regenerated as the catalyst in the solution.
So next, we'll move to the Markovnikov's rule in hydration. According to this rule, the hydrogen atom of the water molecule will attach to the carbon of the double bond that has more hydrogen atom, while the hydroxyl group, which is OH, will attach to the carbon of the double bond that has fewer hydrogen atoms. So the last one, to summarize the hydration of alkene, let's answer the three key questions that I mentioned earlier. The first question is, what are we adding across the double bond? The answer is water molecule. The second question is, where will the group add? Radioselectivity. As I mentioned before, the hydrogen atom will attach to the double bond that has more hydrogen, while the hydroxyl group will attach to the double bond that has fewer hydrogen. The third question is, what is the expected stereochemistry of the added group? The answer is, it is actually depends on the nature of the reagent and condition that are used for the hydration reaction.
My name is Siti Ayuni Ashri Adrin binti Umar Rizal and my metric number is 2318056. In this video, I like to explain about another two examples of addition reaction, which is halogenation and hydrohalogenation reaction of alkenes. Halogenation reaction of an alkene means the addition of halogens such as bromine or chlorine gas on the double bond of alkenes to produce vicinal dihalides. As you can see in the diagram, the example given is propene reacts with bromine gas to produce dibromopropane, while propene reacts with chlorine gas to produce dichloropropane. This is the steps of this reaction. Step 1, nucleophilic pi bond attacks a bromine atom to form bromonium and bromide. And step 2, bromide ion attacks the carbon in bromonium and form 1,2-dibromoethane. This is the summary for this reaction. The first one, halogens will be added across the double bond. And the second one, there are no regioselectivity because carbon and hydrogen bonds form on both sides of the carbon atoms. Therefore, it's impossible to form regioisomers here. And the expected stereochemistry of the added group is anti-addition of vicinal dihalides. Another example of addition reaction is hydrohalogenation reaction in alkenes. This reaction means the electrophilic addition of hydrogen halides such as hydrogen bromide or hydrogen chloride to alkenes to produce haloalkenes or alkyl halide. There are two types of alkenes, which the first one is symmetrical alkenes, which has same substituent at each end of double bond, and the other one is unsymmetrical alkenes, which have different substituent at each end of double bond. For hydrohalogenation reaction in symmetrical alkenes, the halogen will be added to one of the carbon atom and the hydrogen will be added to the other carbon atoms. As you can see in the diagram, the example given is the reaction between ethene and hydrogen bromide to produce ethyl bromide, and ethyl bromide is the only product possible for this reaction. For hydrohalogenation reaction in unsymmetrical alkenes, it has more potential to produce two regioisomers, and in many cases, one regioisomers will have higher in proportion than the other one. For example, propene reacts with hydrogen chloride to produce 2 propyl chloride as major product and 1 propyl chloride as minor product. There are two steps for this reaction, which is the first one is nucleophilic pi bond attacks the hydrogen to generate more stable carbocation in hydrogen halide, and the second step is halide attacks the carbocation and form alkyl halides. Markovnikov's rule will be applied in hydrohalogenation of alkenes. This means halogen will be attached to the carbon of the alkene, which attached to the fewest hydrogen atoms. And the examples given shows the position of the halogen attached to the carbon atoms. Finally, this is the summary of hydrohalogenation reaction of alkenes. Hydrogen atom and halogens such as bromine and chlorine will be added across the double bond, and the regioselectivity will follow Markovnikov's rule, which halogen will attach to the carbon atom which has fewest hydrogen atom, And the expected stereochemistry of the added group is a mixture of syn addition and anti-addition products.
Assalamualaikum, my name is Muhammad Syabir bin Nasir. My matric number is 2313531. So today I will explain to you about nucleophile, electrophile and also free radicals. So let's go to the nucleophile part first. So nucleophile are electron-rich species which are capable of donating electron pairs to form a new chemical bonds. An nucleophile can also be negatively charged, also known as an ion, or neutral molecule with lone pair of electrons. The structure below is the example of the nucleophile. The first one we got water, the second one we got chloride, and the third one we got ammonia. These three examples is considered as nucleophile because of the presence of lone pair of electrons. Now let's go to electrophiles part. So electrophiles is a electron deficient species that have a tendency to accept a pair of electrons. These electrophiles have deficient number of electrons in their outermost shells. Therefore, they tend to accept electrons in the bonding directions. Electrophile can be positively charged or carbocation ion. So as you can see, the three structure below is the example of electrophiles. The first one is hydronium ion, the third one is boron trifluoride ion, and the third one is copper ion. So all of the example have deficiency of electron in their valence of electron. Therefore, they will, in the reaction, bonding reaction, they will receive electron to bond with other molecule. Why is it important for us to understand nucleophiles and electrophiles before learning about the reaction? Because nucleophile and electrophile are the central to the reactions and mechanism. This is because reaction happen because of the movement of electron. By understanding the nucleophiles and electrophile, we will able to determine the donator of the electron and also the receiver of electron. This will help us to understanding the reaction in formation of bond and the breaking of bond. As for example, is nucleophilic substitution reaction, nucleophilic addition reaction, and also electrophilic substitution reactions. All of these examples will be explained by my team later in the video.
Assalamualaikum warahmatullahi wabarakatuh. My name is Harisha binti Muhammad Harmain. My matric number is 2311392, and I will be explaining about the definition of addition reaction. And the reaction can be described in which one molecule combines with another molecule to form a larger molecule with no other products. In short, it means when we combine two molecules to form only one product. And why we needed this addition reaction? So basically, we need this addition reaction to convert from unsaturated hydrocarbon to saturated hydrocarbon. Unsaturated hydrocarbon means double bond or alkenes, and saturated hydrocarbon means single bond or alkene. For example, if we have unsaturated hydrocarbon here, this R here can be the alkyl group or hydrogen. So when we added this unsaturated hydrocarbon with hydrogen gas with the help of nickel catalyst, it will be converted into saturated hydrocarbon, which means the double bond here will break to form a single bond. So this hydrogen will fulfill here, and so there will be H here and H here. So for example, I change the R here into H. So this molecule will become ethene. When we added it with hydrogen gas with the help of nickel catalyst, then it will become ethene because the double bond here will break into one single bond and the hydrogen gas here will be fulfilled here. Okay, there is 4 types of addition reaction. Firstly, hydrogenation. Secondly, hydration. Third, halogenation. And fourth, hydrohalogenation. So, firstly, hydrogenation. Hydrogenation happens when we added H2 here or hydrogen gas. So, as for the example, as you can see, there is propane here, and when we added hydrogen gas here with the help of catalysts or such as nickel, this propane will be converted into propane. Why? Because the double bond here will break apart to form a single bond. So there will be another single bond here, and hydrogen gas will fulfill it. So the product will not have any double bond, and it is a saturated hydrocarbon. Secondly, hydration. Hydration means we need to add water or H2O in the unsaturated hydrocarbon. For example, we have ethene here. When we added H2O here with the help of catalyst, and we also need to fulfill one condition, which is high temperatures. Why? Because we need to turn this water into water vapor or steam, because we need to break the bond from the H2O to form H and OH. So as for the product, this double bond here will break and form a single bond. So there will be another single bond here, and H here will fulfill here, and OH will fulfill here. So we can see there's OH here, which means that this saturated hydrocarbon is an alcohol, so the name will be ethanol. When we do the hydration process, we will get a mixture of ethanol, unreacted water, and unreacted ethene. So how to separate and get only ethanol? Firstly, we need to cool it down. So when we cool it down, the ethene will stay as a gas because it has lower boiling point. And the ethanol and unreacted water here will form a liquid. So by this liquid, we need to form another process named fractional distillation. Fractional distillation means we will put a mixture of ethanol and water in here, and we know that ethanol will boil first before water. So ethanol will evaporate here and then condense here. So that's how we get only ethanol. And the water will be left here. Thirdly, halogenation. Halogenation happens when we added any halogen into the unsaturated hydrocarbon, such as bromine, chlorine, iodine, and fluorine. So, for example, we have ethene here. When we added it with bromine, the product here will be dibromoethene because the double bond here will break and form only single bond. So there will be another single bond here, and bromine will fulfill it. So as for the color, we know that ethene is colorless and bromine is brown. So when we mix it together and we shake it, the brown color will disappear. So the product will become dibromoethene. And lastly, hydrohalogenation. Hydrohalogenation means when we added HBr, HCl, Hi, HF into the unsaturated hydrocarbon. For example, here we have ethene, and when we add it with HBr, it will become bromoethane because the double carbon bond here will break and form only one single bond. So there will be another single bond here. And this HBr also will break into H and Br. So this H will fulfill here and this Br will fulfill here. So that's all for me.
My name is Nur Alia Farisha binti Muhammad Rafi and my metric number is 2310698. For my part, I will talk about what is Markovnikov rule and how to determine which are the major and the minor product. Since we all know that Markovnikov's rule is applied to unsymmetrical alkene, during the electrophilic addition reaction in alkene, we do tend to get more than one possible product. So we want to know which product is more stable as major product and less stable as minor product. So let's go to the Markovnikov's statement. Markovnikov's rule states that in the addition reaction of protein acid HX, for example HCl, HBr, and H2O to unsymmetrical alkene, the H atoms itself attach itself to the carbon atom with the larger number of H atoms. So we want to know the major product first. So if we want to know the major product, H added to C atom with more H. So for example, we have propene here that the double bond attached to carbon number 1 and carbon number 2 and react with HBr. So we need to put the H from the Br at carbon number 1 and carbon number 2 only. So we already put the H from the carbon number 1 and H from carbon number 2. So we want to know the major product, which one is major product. So based on the definition, H added to C with more H. Let's count first carbon. How many hydrogen that attached to the carbon number 1. So for carbon number 1, we have 2H here, and carbon number 2 we have 1H, and carbon number 3 does not include it since there are no double bond attached to it. So based on the definition, H added to C with more H. So the major product is at first carbon because H is attached to carbon number 1 which have 2 hydrogen. So we consider it as a major product, while for the minor at carbon number 2. For my part, I will give the definition of elimination. Elimination is a type of organic reaction in which two substituents are removed from a molecule in one or two step mechanism. For example, we have chloroethane here react with weak base that will produce ethane plus hydrochloric acid. So in chloroethane, we have two substituents which are hydrogen and Cl. So we need to remove the two of the substituents to get the product as ethane and hydrochloric acid. So the chloroethane is the saturated compound that react with weak base to produce ethane, which is the unsaturated compound. So basically, elimination reaction is the opposite reaction to addition reaction.
Assalamualaikum and hi, my name is Anuar binti Azizan. My metric number is 2317964 and I will present the type of elimination and E1 and E2 mechanism. H and OH are lost from adjacent carbon. Sulfuric acid and phosphoric acid are are the acids most frequently used in the alcohol dehydration and act as catalysts. As an example, 2-methyl-propanol react with H2SO4 and will produce 2-methylpropene and water. Basically, OH will leave the group so that alkyl compound can be formed, which is 2-methylpropene. Other alcohol behave similarly, but temperature needed to every alcohol to undergo dehydration of alcohol is very different. Tertiary alcohol need less temperature than secondary alcohol and primary alcohol, while primary alcohol need higher temperature than secondary and tertiary alcohol. Second is about dehydrohalogenation of alkyl halides. Dehydrohalogenation is the loss of ion hydrogen and ion halogen from alkyl halides. When applied to the preparation of alkenes, the reaction is carried out in the presence of a base, such as sodium ethoxide in ethyl alcohol as solvent. As an example, alkyl halide react with sodium ethoxide and will produce alkene, ethyl alcohol, and sodium halide. As you can notice that ion hydrogen and ion halogen, which is X, will leave the group and alkene is formed. Next is about E1 and E2 mechanism. I will talk about E1 mechanism first, and the next slide I will talk about E2 mechanism. E1 is unimolecular elimination reaction. It always occur at temperature above 50 degrees Celsius and react with liquids. Let's look at example. First step, alpha carbon lose the halogen X. Hence, the positive charge appears on the alpha carbon. This form we call as formation of carbocation. Secondly, a nucleophile will attack on this beta hydrogen. As a result, it loses hydrogen and we get a double bond compound. And the rate of E1 reaction. Tertiary alkyl halide is the faster rate of E1 elimination. Meanwhile, primary alkyl halide the slowest rate of E1 elimination. Next, I will talk about E2 elimination reaction and mechanism. What is E2? E2 is a bimolecular elimination reaction. Because it is an E2 reaction, so that means we are going to produce that predicated alkyl halide that's going to have an elimination rate. Let's look at an example here. We have an alkyl halide reacting with strong base, and we can see that always take off a beta hydrogen, and it's called as beta hydrogen elimination. So I take my minus and grab a beta hydrogen, as you can see at the first image. Next, the second arrow, if you look at the second arrow, the electron from the beta hydrogen will make a double bond and finally kick out the bromine, as you can see at the third arrow. Finally, we will get a double bond water and the leaving group iron bromide. And next, you can see at the rate of reaction. Alkyl iodide, Ri, is the faster rate of elimination, and meanwhile, alkyl chloride is the lowest rate of elimination.
Bismillahirrahmanirrahim. My name is Muhammad Wadid bin Muhammad Zaini. My matrix number is 2317149, and today I'm going to explain about the principle of Zafri. So Zafri is actually the rule that is used in elimination reaction, whether it is from dehydration process, also from dehydrohalogenation process, where alcohol and haloalkene become alkenes. So Zafri is used to determine the major product of the compound, because sometimes different elimination reactions may produce more than one alkenes. It is because in that compound we have two different beta carbon. As we know from the elimination reactions, we need to remove hydrogen from the beta carbon. So in this case, we have more than one beta carbon. So we need to determine which beta carbon that we need to remove the hydrogen. So how to determine the major product? The major and minor products are predicted based on the number of alkyl group attached to the alkene. So let's take a look at the example so we can understand more. Alright, so let's take a look at this example where 2-bromobutene undergoes dehydrohalogenation process. So it can form two possible products where it can produce 2-butene and also 1-butene. So in these cases, how can we determine the major product and also the minor product? So we need to remember back the principle of Zafri, where it says that the stable and also the major compound is the compound that has more substituted double bond with alkyl groups attached to it, attached to the double bond. So let's take a look first at 2-butene. At the double bond attached with two alkyl groups, where 1-butene, the double bond, it only attached with only one alkyl groups. So in these cases, the 2-butene is the major product, while the 1-butene is the minor product, according to the Zafri. Alright, next we're going to take a look about the last reactions, which is the substitution reaction. So the definition of substitution reaction is a reaction in which the functional group of one chemical compound is substituted by another group, or it is a reaction which involves the replacement of one atom or a molecule of a compound with another atom or a molecule. So in substitution reaction, we just simply substitute another atom or molecule with an atom or molecule from another compound. So in substitution reaction, we can obtain many functional group For example, we can obtain haloalkane from alkane using substitution reactions. So in substitution reaction, we have three general classes. The first one is nucleophilic substitution, where our substituent is an electron rich, which provides electron pair to make a bond with substrate. The second one is electrophilic substitution, where now our substituent become deficient electron. So the one that provides the electron pair is our substrate. So it's slightly different from nucleophilic substitution. And the last part is free radical, where we have three phases in free radical. The first one is initiation, the second one is propagation, and the last part is termination. So we're going to take a look about the example. Alright, now we're going to take a look at this example where methane, CH4, will react with Cl2, which is chlorine gas, to form chloromethane and also hydrogen chloride. So in this reaction, we can see that one of the chlorine molecule replace one of the hydrogen atoms in methane, resulting in the formation of chloromethane, CH3Cl, and hydrogen chloride. So in this reaction, we can see that from alkane become haloalkane. This reaction involves the free radical, where we have three phases. The first one is initiation, the second one is propagation, and the last one is termination. So in initiation, the chlorine molecule Cl2 is broken apart into two chlorine radicals by the energy from UV light or heat, where in propagation is the part where one chlorine radical abstract a hydrogen atom from methane, forming hydrogen chloride and a methyl radical, CH3. So the methyl radical then reacts with another chlorine molecule, replacing the hydrogen with a chlorine atom. So in this phase, the chlorine radical will take one hydrogen from methane, forming hydrogen chloride. And also this methyl radical CH3 will take a pair of chlorine to replace the hydrogen that already taken from the chlorine radical to form CH3Cl, whereby in termination part, the radical combine to form stable molecule, terminating the chain reaction.
Yeah, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syamim bin Shazura Bani and my metric number is 2317617. Now I'm going to continue about the type of substitution reaction. Okay, if we want to figure out the organic substitution reaction, we have to know three things. sp3 hybridized carbon, which we are going to call the substrate. Second, a leaving group, which is an atom that can accept electron density. Okay, and last, nucleophile, which is an atom or group contains lone pair or pi bond. There are two types of substitution that I'm going to talk about. The first one is SN1 mechanism and SN2 mechanism. Okay, we're going to discuss about SN2 mechanism first because it is much more easier. The reaction only involves primary and secondary carbocation. Okay, this mechanism also has one step only. Okay, we can take a look at the example. Bromomethane react with acetate. Okay, the bromide ion in this compound will act as the leaving group and acetate will act as the nucleophile. In SN2 mechanism, there is no carbocation intermediate, and nucleophile plays much more active role in this reaction. Okay, the nucleophile, which is acetate, approach the opposite side of leaving group and do a backside attack. Then it push out the leaving group and the stereochemistry of the compound would be inverted. So we can see the methyl acetate form. Okay, we can take a look at the energy level diagram. There is only one energy barrier formed in this reaction because, like I said just now, there is no carbocation ion intermediate in this reaction. The reaction also occur the front side attack. But when front side attack occur, the nucleophile will approach the same side of the leaving group. So all the other groups remain and in their original position. So the front side attack results in retention of configuration around the stereogenic center. Thus, the SN2 reaction will only proceed. The SN2 reaction will only proceed with a backside attack of the nucleophile, which results in inversion of configuration at the stereogenic center. Okay, now we're going to talk about SN1 mechanism. It only involves the tertiary carbocation. This reaction mechanism has two steps, which is formation of carbocation and the nucleophilic attack. Okay, first, formation of carbocation is the rate determining step. We will rate the leaving group, which is bromide ion, to leave from the molecule with its electron and give the compound positive charge. Then the reaction will take a while, and the rate determining step is called slow step. So next, the nucleophile will attack this intermediate and a bond is formed. It is like the acetate quickly hops off into the molecule. Since this reaction happens quickly, it doesn't determine the overall rate. Okay, we can take a look at the energy level diagram. There has two energy barrier. The first activation energy is higher than the second activation energy because the first activation energy involve bond breaking, while the second one involve the bond formation.
So now I will explain to you about the real life application of this reaction. The application that I choose is the hydrogenation of the vegetable oil. This hydrogenation of the vegetable oil is a chemical process used in the food industry to convert liquid unsaturated fats, which is oil, into solid or semi-solid fat, which we can say as margarine. This reaction involves the addition of the hydrogen molecule to the carbon-carbon double bond present in unsaturated fatty acid with the presence of nickel as catalyst. The equation is as shown below, which is vegetable oil plus hydrogen, with the nickel act as a catalyst to produce hydrogenated vegetable oil. It will break during the reaction and will form bond with hydrogen to form a hydrogenated vegetable oil. Each of these have its own properties. For the vegetable oil, we can see it will be liquid at room temperature and it has many carbon-carbon double bond. As for the properties of hydrogenated vegetable oil, this process will cause the fat to harden. In other way, we can see that it becomes solid or semi-liquid and becomes solid at room temperature and has a higher melting point and also can be known as margarine. This process will save a lot of space and help the industry to easily store the oil in a container without thinking about it spilling, because it's in the solid form now.